In this tutorial, I'll walk you through how to create an object detection model for cat prediction using RoboFlow. In the previous video, we explored how to deploy the RoboFlow Streamlit application on OpenHub using the Oikeos platform. If you haven't seen that video yet, the link is provided in the description below. Now let's get started. To begin creating your model, click the Login/Signup button. This will take you to the RoboFlow platform. You can simply click Continue with Google. Once you're logged in, click on New Project. Enter a project name based on your model. In my case, I'm naming it Cat Prediction. Make sure to choose the appropriate project type and annotation group depending on your dataset. Next, enter the annotation group for your model. I'm using cat as the group name. Right next to it, you'll see the license option. Select Public Domain from the drop-down and leave the remaining settings as default. Then, click on Create Public Project to proceed. Once your project is created, you'll be taken to the project dashboard. From here, click on Select Folder to upload your dataset directly from your system. Make sure your images and annotations are properly organized before uploading. In my case, I've saved some cat images in a folder named Cat1 on my system drive. I'll select that folder and click Upload to start importing the dataset into RoboFlow. After importing the dataset, click on Save and Continue. This will begin the image uploading process for labeling. Once the upload is complete, you'll see an option to start labeling. There's also a Start Auto Label button available, but in this demo, I'll proceed with manual labeling by clicking Start Labeling. You'll now be taken to the manual labeling page. At the bottom, click on the Assign to Myself button to begin labeling the images. Now, click on the Start Annotating button. Then, hit Get Started to begin labeling your images. You'll now be able to draw bounding boxes around the objects, in this case cats, in each image. On the left side, below Annotations, you'll see two options: Classes and Layers. Click on Layers. Now, draw the bounding box around the object in your image, in this case, the cat. Once you draw the box, the annotation editor will appear with the label cat. Click Save to confirm the annotation. While labeling or reviewing your images, you can click the side arrow button at the top of the page to move to the next image. You can also follow the same process by selecting the Classes option instead of Layers. Annotate all your images by drawing bounding boxes and labeling them accordingly. Now, I'll demonstrate this annotation process on 5 sample images to show you how it's done. Once you've finished annotating, go back to the previous page to verify that all images are properly annotated. Now you can see that all the images have been successfully annotated. Once everything looks good, click the Submit for Review button in the top right corner of the page. Now click on the Review box to begin reviewing your annotated images before moving forward. This allows you to double-check your work and ensure everything is correctly labeled. Click the Approve All button to confirm and finalize all your annotations. Then, click the Add Images to Dataset button to include the labeled images in your project. You'll now be taken to the Add Images to Dataset page. Here, under the method, select the option to split images between train/valid/test. This ensures your dataset is properly divided for training, validation, and testing. Once selected, click the Add Images button to proceed. Now, the RoboFlow Instant Model has started generating. It's being fine-tuned on your dataset automatically. Click on the RoboFlow Instant Model preview, and you'll see it predicting on your previously uploaded image with 100% confidence labeled as cat. To go back, click the arrow button to return to the previous page. Click the Train Model button located at the top right corner of the page. Then choose Custom Training option. You'll be redirected to the version page. Under the Process section, simply click Continue. Do the same under the Augmentation section. Finally, click the Create button to start training your model. Next, select Custom Train. Leave the default model architecture as RoboFlow 3.0 YLOV8 and click Continue. On the next screen, you'll see the model size option. By default, it's set to fast. Click Continue, and finally, hit the Start Training button to begin training your model. Now you'll see a pop-up message showing Training in Progress. Simply click the OK button to confirm and let the training continue in the background. After confirming, you'll see that the model training has officially started. During this phase, RoboFlow automatically begins optimizing hyperparameters like learning rate, batch size, and augmentation settings for better accuracy. RoboFlow provides an estimated time, in this case, around 19 minutes to complete the training. You can now sit back while your cat detection model is being built in the background. I waited approximately 19 minutes for the training process to reach near completion. Now, the model shows just 49 seconds remaining, and once that finishes, model evaluation will begin automatically. This step assesses the performance of your trained model using validation and test data. For the model evaluation phase, you'll need to wait for around 2 minutes. I waited approximately 2 minutes for the model evaluation to complete. RoboFlow has now finished analyzing the results. Now click Version. Click on View on Universe to explore your trained model on RoboFlow Universe. Click the model. At the top of the page, you'll find the project URL in your browser's address bar. This is your unique link to the model hosted on RoboFlow Universe. Now, scroll down the page and you'll find the API key for your trained model. This key allows you to integrate your cat detection model into applications. Copy the project URL from the top of the page. Next, switch to the Streamlit application and click on Object Detection, RoboFlow Train. This loads your trained model into the app, so you can test it with live or uploaded images. Now, paste the project URL into the input field on this page. In the same way, scroll down in your RoboFlow project to find the API key. Copy it, then paste it into the private key field in the Streamlit application. Now, click the Browse File button. Select a cat image from your device, and then click Open. Next, click the Verify and Load Model button. You'll see your uploaded image alongside an inferenced image with a bounding box around the cat. The app will also display the predicted class and confidence score, along with a pandas data frame showing the detailed results like class name, confidence, width, height, etc. Thank you for watching. If you have any questions or need clarification on any part of this tutorial, feel free to reach out in the comments or contact us directly.